On December 17, 1939, Captain Hans Langsdorff stands on the bridge of the Admiral Graf Spee, facing a decision that does not exist in the Naval Handbook. He commands one of the most advanced warships on Earth. His vessel is afloat, his main battery is operational, his crew is ready to fight. But the captain is staring at an equation with only one honest answer: loss. He has two options. He can sail his ship out of the Montevideo harbor into the Atlantic and fight the British squadron waiting for him, or he can destroy his own vessel in the shallow water of the River Plate. Option A is a technical impossibility. Option B is a violation of every instinct a naval officer possesses. To understand why a commander would choose to execute his own ship, we must look inside the hull at a single broken component. The Graf Spee is a Deutschland-class Panzerschiff designed to cheat the Treaty of Versailles. She is lighter than a battleship, but armed with 6 11-inch guns that can throw a roughly 300-kilogram projectile, the weight of a motorcycle, out beyond 20 miles. She is powered by 8 massive diesel engines, giving her a range of over 16,000 nautical miles. For months, she has been a ghost in the southern oceans, sinking about 50,000 gross register tons of Allied shipping. But 3 days ago, during the Battle of the River Plate, the British heavy cruiser Exeter landed a projectile that changed the physics of the war. It was not a fatal blow to the hull or the magazines. It was a hit that targeted the ship's ability to stay alive at sea. The 8-inch shell struck machinery tied to fuel cleaning and auxiliary services, the system that keeps the diesel fit for sustained running. What survives in the record is not one neat number, but one hard conclusion. Graf Spee could not count on her fuel purification for a long ocean passage. Some accounts cite capacity for only about 1,200 miles of already cleansed fuel, while a later German signal claimed as little as 16 hours of steaming. The numbers vary, the trap does not. She has endurance for a fight, not for a run, because if Langsdorff sails, the ship risks losing power far from land, drifting defenseless under British guns. And then comes the second weapon, the weaponized lie. In Montevideo, British agents seed the air with false intelligence, fake radio traffic, phony phone calls, and rumors planted where German ears will hear them, until overwhelming force feels inevitable. Names are dropped like weights: Renown, Cumberland, even French ships in the imagination, until the bluff becomes a fleet inside one man's head. The force outside the estuary was not the unstoppable armada the rumors described, but Langsdorff believes it is there. He believes he is sailing into a firing squad. So the options collapse into one reality: he can fight once and die, or he can deny the enemy what his ship carries. Salvage logic takes the bridge. At sunset, the Admiral Graf Spee moves slowly out of the harbor. She does not turn toward the sea. She stops in shallow water, roughly 8 to 11 meters deep, close enough for the world to watch what comes next. The crew is evacuated to tugboats. A skeleton team of engineers moves through the internal compartments, rigging the final mechanism. They do not simply open valves and hope the river will do the work. They lay scuttling charges and disperse what ammunition remains, choosing points that will cripple the ship from within. This is not a quiet sinking. It is a deliberate destruction. The charges ignite in a chain of fire and concussion. The ship settles into the mud, wrecked and burning, while flames climb through shattered compartments. The smoke is visible from shore, and the wreck burns on in the shallows for the next 2 days, blackening the sky over Uruguay. The captain believes he has saved his crew and destroyed his ship's secrets. He is wrong. The water is too shallow. The superstructure remains visible above the surface. The Graf Spee has not vanished. She has merely parked, and the British are already writing the check to buy her back. 14,000 pounds sterling. That is the figure that surfaces in the wake of the Scuttling, not as a fantasy of owning a warship, but as a legal grip on what could be taken from it. Britain's minister in Montevideo, Eugen Millington Drake, persuaded a local businessman to buy the salvage rights for that sum. Then a scientific intelligence specialist, Labouchere Hillier Bainbridge Bell, arrived posing as a scrap metal dealer, close enough to inspect the wreck, close enough to bring key parts back for analysis. The warship did not change flags, but the secrets on her mast and in her fittings were suddenly within reach. To understand why British intelligence would pay cash for a burning pile of German steel, we must analyze the physics of the kill. When Captain Langsdorff gave the order to scuttle, he was not trying to hide the ship. He was trying to break it. Scuttling is usually a passive process. You open the seacocks, you flood the compartments, and you let gravity pull the hull down. But the German engineers chose a violent alternative. This is the concept of scuttling physics. The goal is not just loss of buoyancy, but total structural negation. They did not trust the water alone. They took torpedo warheads from the armory and suspended them from the overhead beams in the engine rooms and the munition magazines. The resulting detonation was designed to snap the ship's spine. The blast wave traveled down through the steel framing and blew the double bottom out of the vessel. The 11-inch gun turrets jumped in their barbettes. The ship did not sink gracefully. It collapsed onto the riverbed. For 3 days, the fires raged hot enough to warp the armor plating. But the German plan had a critical flaw. They had underestimated the river plate's shallows. Graf Spee broke, burned, and settled, yet she never disappeared. The upper work still broke the surface like a steel island, and on that exposed structure sat a broad rectangular aerial, Seetakt radar, one of the earliest German naval radar sets to go to sea, and among the first fitted to a major German warship. The British knew it mattered. They wanted to understand what it could see, and how far. While the wreck was still cooling, British intelligence moved in. They did not arrive as commandos. They arrived with paperwork and cover stories. Men who looked like industrial salvors and behaved like inspectors. Under that guise, they examined the exposed equipment and took what could travel. Seetakt components, small enough to carry away, valuable enough to dissect. The river does not let steel sit idle. The Graf Spee is resting on silt and clay that behaves like slow-motion quicksand, and 16,000 tons of steel will not stay perched on that kind of ground. Decade by decade, the wreck subsides. Lower, darker, harder to reach, until, in some periods, only small parts remain above the surface, and most of the ship is swallowed by the estuary's patient movement. In the world of underwater, salvage visibility is usually measured in feet or meters. In the River Plate estuary, it is measured in inches, and often the number is 0. A diver descending to the Admiral Graf Spee enters water so thick with suspended sediment that light simply stops. By 25 feet, he is blind. 3 inches from his mask, his own hand disappears. This is the operational environment that confronts the modern salvage effort in 2004. An operation led by Uruguayan diver Hector Bado, with maritime archaeologist Mensun Bound, among those involved in the work around the wreck. They are not swimming in water, they are swimming in a fast-moving soup of silt and clay. In here, sight is useless. The diver has to work by touch. The survey process becomes a game of industrial braille. The diver moves through the black water, pulling himself along a guideline. He must build a 3-dimensional map of the wreck in his mind, using only the feedback from his gloved hands. He feels for the rivets, the jagged edges of torn steel, and the smooth curvature of armor plate. Every movement is a risk. In the darkness, it is easy to become snagged on a piece of debris or a collapsing bulkhead. The river current pushes against him constantly, threatening to disorient his internal compass. The team is looking for a specific needle in this haystack of mud. They are hunting for the ship's fire control center. The Graf Spee was famous for its Seetakt radar, the technology the British stole in 1940. But the radar antenna was only the eyes of the system. The brain was the 27-ton optical rangefinder, a massive armored instrument that calculated the firing solutions for the 11-inch guns. The historical record suggests the rangefinder fell from the superstructure during the scuttling explosions. But where is it now? The bottom of the river plate is not a static floor. It is a dynamic geological conveyor belt. Over the decades, the heavy steel components of the battleship have not just sat on the bottom, they have subsided. The hull acts like a heavy stone on a soft mattress. The rangefinder has likely sunk deep into the sediment hidden from sonar and side-scan imaging. To find it, the team must use a combination of magnetic anomaly detection and physical probing. They are stabbing steel rods into the riverbed, hoping to hit metal. It is a slow, exhausting process. Hours of searching yield nothing but mud. Then a probe strikes something hard. A diver descends the line. He reaches into the silt and finds a ring of metal where no riverstone should be. He traces the shape by touch. Armored, cylindrical, massive. The team believes they have found the fire control rangefinder. But the survey reveals the real problem. The component is embedded deep in clay, packed tight by decades of silt. The target is identified, and the river is holding it like a fist. The 27-ton optical rangefinder of the Admiral Graf Spee is a geometric prisoner. The team has located it, but the river has locked it into the clay, not resting on the sediment but buried inside it. This introduces the concept of mud suction and breakout force. When a heavy steel object sits in fine silt for 65 years, the water between the object and the seabed is squeezed out. A vacuum seal forms. The mud acts like a massive industrial glue. To lift the object, you do not just have to overcome gravity, you have to overcome the suction of the earth itself. The calculation is brutal. The surface area of the rangefinder in contact with the mud is vast. If the crane operator simply applies 27 tons of tension to the lifting cables, the rangefinder will not move. If he increases the tension to 40 tons, he risks snapping the wire ropes or ripping the lifting lugs out of the historic steel. The seabed does not negotiate. The force required to break the suction seal can be 3 times the actual weight of the object. The crane on the salvage barge Hector is powerful, but it cannot fight the entire riverbed. To rip it free by brute force would destroy the artifact or capsize the barge. The solution requires nerve and control, not brute force. The team has to relieve the suction that has locked the artifact into the clay, carefully loosening the mud around and beneath it so water can re-enter and pressure can equalize. It is slow work done by feel in a place where visibility is often nothing and the current never stops pushing. One mistake can turn an engineered recovery into a catastrophe. For hours, the divers work in shifts, blasting channels through the clay to break the vacuum. They thread the heavy wire strops through the tunnels, cradling the rangefinder in a steel basket. They are building a cradle, blindly feeling the load points with their hands to ensure the steel cables do not slice through the softer bronze fittings. On the surface, the crane takes the strain. The cables go tight. This is the critical moment in the load path. The tension rises. The barge dips low in the water. The engineers watch the dynamometer readings, waiting for the spike that indicates failure or freedom. For a long moment, nothing happens. The mud is holding on. Then, with a sudden shudder, the suction breaks. The vacuum collapses as water rushes into the void beneath the hull. The rangefinder lifts free from its tomb. It rises through the black water and breaks the surface for the first time since 1939. The water cascades off the preserved armor. The glass lenses are still intact. The team has proven that the recovery is possible. They have defeated the mud, but their success has opened a far more dangerous problem. The survey has identified another target nearby. It is lighter than the rangefinder, weighing only 800 pounds. From an engineering standpoint, it should be an easy lift. But this object is not just a piece of machinery. It is the bronze eagle that once adorned the stern of the ship. And in its talons, it holds a symbol that will turn the physics of salvage into a political crisis. Archaeology is usually about revealing the truth. But on the Admiral Graf Spee, the truth is toxic. The salvage team faces a dilemma that is not engineering-based but ethical. They know the location of the ship's stern ornament. It is a massive bronze eagle, roughly 9 feet across, and on the order of 350 to 400 kilograms in weight. Heavy enough to demand machinery, small enough to vanish forever if the mud takes it. From a technical standpoint, recovering it is the only way to save it. But from a political standpoint, touching it is exploring a minefield. The urgency to lift the eagle is driven by a chemical time limit known as galvanic corrosion. This is the concept that forces the team's hand. The Graf Spee is constructed of steel, but the eagle is cast from bronze. When you submerge 2 different metals in an electrolyte, and an estuary like the River Plate is exactly that, a mixing zone of fresh and seawater, and connect them physically, you create a battery. The electrons flow from the active metal to the noble metal. In this reaction, the steel of the hull acts as the anode. It sacrifices itself to protect the bronze cathode. For 67 years, the bolts holding the eagle to the ship have been dissolving. The connection is failing. If the bolts snap, the 800-pound artifact will fall face down into the liquid mud. It will sink beyond the reach of any diver and be lost forever. The team must intervene now or accept that the history will vanish. On February 10, 2006, the salvage barge Hector positions itself over the stern. The divers descend once again into the zero visibility current. They cannot tunnel under this target. They have to unbolt it by touch. They work with wrenches and cutting tools fighting the corrosion that has fused the fasteners. It is a surgical operation performed in the dark. This moment carries a heavy irony. During her operational life, the Graf Spee was a master of deception, sometimes altering her silhouette with temporary dummy structures so distant observers would hesitate, just long enough for a raider to close the gap. She lived by hiding her identity, but the object coming up the wire now is the one part of the ship that cannot be disguised. The crane engages. The load is light compared to the rangefinder. There is no struggle with mud suction this time. The Bronze Eagle breaks the surface. As it rises, the water washes away the silt, revealing the detail of the casting. It is a magnificent piece of Art Deco engineering, but below the talons inside a wreath of oak leaves is the symbol that stops the conversation, the swastika. In an instant, the mission changes from a salvage operation to an international incident. The German government issues a protest. Jewish advocacy groups express concern that the artifact could become a shrine for neo-Nazis. The Uruguayan government is caught in the middle. The team had plans to raise the entire ship. They had the engineering solution to cut the hull into sections and lift it. But the appearance of the Eagle creates a political firewall that no amount of hydraulic power can breach. The recovery of the symbol scares the authorities. They do not want the rest of the ship. They do not want to see what else is down there. After that, further recovery becomes harder to justify, not because the engineering fails, but because the symbol changes the risk calculus for everyone in power. The Eagle is not simply placed on a museum plinth. It is kept out of public reach, in naval custody, while courts and governments argue over ownership and what should be done with it. The project's momentum bleeds away. The Graf Spee is not raised. The hull is sentenced to remain in the river. They beat the mud. History beat them. The Admiral Graf Spee is currently dying a second death. The first death was a spectacle of fire and explosives in 1939 that was watched by thousands of people from the shoreline. The second death is a silent, slow-motion erasure that is happening right now beneath the brown surface of the river plate. The wreck is subject to a geological force that is more final than any scuttling charge. The hull is subsiding. 16,000 tons of steel is heavier than the sediment it sits upon, and year by year the ship sinks deeper into fluid mud. What once stood proud is now almost entirely submerged. The river is not just covering the ship, it is digesting it. This geological inevitability brings us to the final conflict of the salvage operation: war grave and heritage law. In marine salvage, possession is often treated like power. But a warship is different. Under widely recognized principles of international law, a sunken warship is not presumed abandoned simply because it lies on the seabed. Sovereign immunity can survive underwater, and salvage rights and permits do not automatically transfer sovereign title. That is why the Graf Spee's ownership story becomes a knot. Britain bought salvage rights in 1940 to get at the radar. Modern Germany asserts moral control over the artifacts to prevent Nazi glorification. Uruguay controls the waters and the access, and private investors, having risked millions to raise the rangefinder, expect a return. The result is a stalemate that has frozen time. The Bronze Eagle does not sit in a museum where the public can learn from it. It sits in a wooden crate inside a guarded naval warehouse in Montevideo. It is hidden from view, caught in a legal limbo where no one can agree on its future. Some argue it should be melted down into scrap blocks to destroy the symbol. Others argue it should be displayed as a warning from history. Until the courts decide, the most controversial artifact in South America remains a prisoner of its own symbolism. Because of this dispute, the ambitious plan to raise the entire hull has been abandoned. The engineering team has dispersed. The cranes have moved on to other jobs. The cut and lift operation that would have brought the pocket battleship back to the surface will never happen. The risk is too high. The politics are too toxic. The success of the Eagle lift actually killed the project. The Admiral Graf Spee achieved exactly what Captain Langsdorff intended in 1939. He wanted to deny the enemy the use of his ship. He wanted to ensure that the technology and the hull would never serve another flag. He succeeded. Today, the only marker for the ship is a navigational buoy and the occasional ripple in the current where the water flows over the submerged armor. The rangefinder and the Eagle came up. The ship itself remains condemned to the dark. The mud will continue to rise, the steel will continue to corrode, and eventually the river plate will finish what the scuttling charges started. The ship will vanish completely, leaving nothing behind but the coordinates of a question that can no longer be answered.